2019. I've been joining Agent Starkware 3 years ago as a product manager and blockchain research. There I did EIP, different things. I worked on EIP 2028, which was one of the biggest EIP of 2019. EIP, Ethereum upgrade, basically. If you're not familiar with the term, I worked on DAM, on DeFi pooling, if you're familiar. I was a product manager of Immutable, savoir, and Diversify. And for the last 6 months, I've been leading with the launch of Starknet. I've been leading the ecosystem team, meaning doing 3 things. The BD side of Starkware, both Starknet and Starknet and Starknet. And on the education side, explaining why how Caro works, and making sure the content, we can produce content and for the community and around Caro and Starknet. And finally, my task mostly is reaching out for the early adopters, and making sure they're happy, providing the right tooling, the right information, introductions, financing, and so on and so forth, various things. And so, yeah, that kind of covers where I stand, and that's it.
All right, really nice. We are gonna proceed with some question to talk about zero knowledge proof.
Sure. Do you want me to? So yeah, your question, or do you want me to go with the presentation?
You can go with your presentation if you want, and after we can talk about the question that we have, if you want.
I mean, maybe let's start with the question. How technical is the crowd? I must ask.
I would say that there are some people who are well aware of it, and some who are around. So
let me just can you allow me to share, and I will just do a presentation explaining how things work. Why we care, why we do all those things, and so on.
Yeah.
So okay, great. You allow me? Yes. Okay, great. So perfect. Okay, great. Allow me to just put on my slides. So yeah, I already said that. If you want to follow me on Twitter, it's GTHL. So let me just start with something simple, what we call a layer 2. What is a layer 2? I mean, I'm gonna dive first of why we need scaling and how it works, and then I will explain a bit more about layer 2. So let's start with this. So there is a paradox about blockchain, which is blockchain are, they're relatively recent, and at the same time, they are insanely slow. And so why? Slow compared to banks, credit card, Alipay, Visa, whatever. And so why? And the reason is because the traditional system works through what we call delegated accountability, trusted parties. And sometimes to send money to you, I will need to go through 10 different intermediaries. And so what blockchain bring into the mix is what we call inclusive accountability. The first very famous mantra of Bitcoin is don't trust, verify. And so this thing breaks both 2 things, privacy and scalability. Why? Because people need to understand this. Because since everyone in the network needs to verify that everything that happened within the network, the scale of that chain is limited by the smallest device that will run on the chain. And so just to be clear about this, when you compare the TPS of Bitcoin versus the TPS of Ethereum and the TPS of Solana, and I'm assuming you know all those chains, you are not comparing the same thing. You're comparing apple to orange to watermelon. Truly. I'm going to explain what I mean by that. The reason is because you need to understand the Bitcoin target machine, meaning the machine you need to run the Bitcoin network as defined by the Bitcoin community is a Raspberry Pi. And the Raspberry Pi is a device you can buy for $40 in any website. And you can run it and plug it, and you will run it forever. Ethereum says, you know what, maybe Raspberry Pi is a bit too limited. Let's have a bit stronger machine. So a bit stronger machine would be a $40 machine on OpenOcean per month, or a $2,500 laptop. So, not the same scale of cost. And Solana says, you know what, that's even bullshit. The people who want the network, they can also pay $500 to $5,000 a month. And it really depends on what machine you're targeting. And the cheaper the machine, the more decentralization you get. But it's a constraint that you get less transaction, less throughput. Okay, makes sense so far?
Yeah, perfect for now.
Thank you, great. So how do we scale this inclusive accountability? So we have two models. We have the centralized word, trade finance, and we have the blockchain. And so why does it scale on centralized finance? Is because they have fucking big computers. Google has data centers, and they will run those petabyte of data all the time. And Bitcoin struggle to process 1 megabyte every 10 minutes. So what can we do? Then what we can do, for instance, we could imagine, say, you know what, fuck it, let's increase the block size. And basically increasing the block size is equivalent to increasing the hardware requirement. And you are excluding people from the network when you do that. So that's why I was going back to my Bitcoin versus Ethereum versus Solana analogy. Basically, increasing the block size is what Solana goes for, which is fine. It's just a trade-off you're making. And so what fraud-proof does, and optimistic rollups does, is a bit different, is to say, let's assume there is somewhere within the network at least one honest big computer. And by my definition, this is not scaling, because scaling for me, and this is my definition, you can agree or not, we can discuss it, but it is more transaction for the same hardware. So optimistic rollup do not bring that. They say, let's bring an additional assumption, which is there is a at least one validator that's going to come up and raise their hand if something's wrong. I'm just going to go very briefly after that into the difference between, layer twos. And that's maybe the good place to start. Because I briefly talked about optimistic rollup here, and I don't know if everyone is familiar, but this is where we sort of shifted in terms of scale, in terms of solution. So when it comes to scaling, you have sort of two approaches. You have like the side chains and the L2s. And so what is the difference between the side chains? What is the difference between an L1, so a blockchain, a regular blockchain, a side chain, and a layer 2? Okay, so an L1 is like a regular blockchain, is a blockchain that basically is only aware of itself. A side chain is a bit different. A side chain is a separate blockchain, but the validators of that blockchain have what I call a protocol level bridge, meaning every validator is within that second chain is aware of what's going on in Ethereum, for instance. So the security of the system is still with the consensus and the rules of the new blockchain, but those validators are supposed to be aware of what's going on in Ethereum. Okay, and now an L2 is a tiny bit different. And that an L2 is a new blockchain also, a layer 2, is a new blockchain that from start says, I don't want to manage the consensus. I'm removing myself the right to achieve consensus. And now what I'm going to do is that I'm going to use the consensus of another layer, another blockchain, like say Ethereum, and I'm going to prove to that other chain that what happened in my chain was correct. And so now you have two types of system. You have the fraud-proof system, the optimistic rollups, and you have the validity-proof system called ZK rollup. And so ZK rollup brings scale because what they do is the following thing. They, instead of having, everyone verifying everything, what they do is the following. They're separating the notion of a prover and a verifier. So today, when you think about it, every time a miner creates a new block, he's going to verify an operation, an transaction, right? A predefined number of transactions. And every verifier that comes after will do the same operation. It will take them the same amount of time. Because there is a pure symmetry in what we call naive replication. Blockchains are distributed databases that works under the assumption of as replication state machine. That's what we call them also. There are a state machine, meaning they're a database which evolved from step one to step two. And everyone in the network is going to rerun everything and naively. So what ZKP brings is that they enable to separate the prover, the first guy who does that work, from the rest of the world. And the cool thing about it is this, the scalability. The prover, this miner, this sequencer, is going to work a tiny bit more. We call in computer science n-log-n, which is complexity, but basically it's called almost equivalent to just running the thing naively. But every other verifier in the network, every other node will have an exponential speed up. They will take what will take you 1 week to prove will take you 1 second to verify. You can think about it as a compression technique. Okay, great. So now they don't need to verify because what they get is the prover is going to prove what we call a state transition, meaning the database is at a state number 1. And now here is a bunch of transactions happen. And here is a new state. Here are the new balances of the database. And here is the proof of the database to be true. Okay. And so this is how scaling works under zero knowledge proof. We are compressing transaction into a small, very small proof, and verifying is super fast and can be very cheaply verified on Ethereum. Make sense so far? If you have any questions, feel free to raise your hand. If you can monitor,
yeah,
I'm not looking at the chat, so feel free to monitor and tell me if any questions arise. Is the level of explanation good enough? Too high level, too low level? Please tell me.
I think for now it's perfect.
Okay, great, awesome. So Starkware is, I mean, I'm going to say braggingly, we are the leading ZK L2 and probably also the leading L2 altogether. By L2, Polygon, for instance, for now is not an L2, it's a sidechain, just to be clear about that. Okay, so now let's continue there.
Could you just explain why Polygon is just sidechain for now?
Okay, because that's exactly a very good question. Because in my distinction between a sidechain and an L2, there is this notion of consensus. Polygon has its own consensus system called the proof of stake using Matic. So the security of the system, the consensus around the chain is done by that proof of stake, which is not the same consensus Ethereum. But what Polygon has, they have their bridge. And the bridge is sort of something that every validator in the system are aware of, which makes it a protocol layer bridge. So they are a sidechain there. But an L2 doesn't work this way. An L2 doesn't have consensus. They have, it's a bit more complicated than this, but for all purposes, it doesn't have consensus. And the consensus, then what the L2 does is it's proving to the L1, to Ethereum, that what happened is correct. And really, you need to understand this. An L2 is a blockchain, but it's a blockchain that is modular in this following sense. Historically, when you look at an L1, the blockchain did 3 things at the same time, which was consensus, agreeing on the state of the system, on what is the current representation of the system, of the database, execution, meaning running transactions and verifying them, and data. What is the database made of? And I saw a question, I'm just going to finish my sentence here. And what ZKP brings into the mix is that we realize, and all of this was guaranteed by decentralization, by the 51% protection, whatever. But what ZKP brings, that it shows that you can actually externalize the execution from the consensus. You can run things and verifying them. It doesn't require everyone to verify everything. And so the cool thing about this is that it sort of breaks down the 3-dimensionality of what a blockchain is, which is consensus, execution, and data. And now you can, since you sort of show that you can have execution out there, then you can actually take the data also elsewhere. And that's what Celestia is doing, for instance, if you're familiar with Celestia. So this is what Polinia called the modular blockchain paradigm. And it's basically saying, I can have a very tiny consensus chain, have the execution done on the L2, proven to the consensus chain, and the execution can say, oh, here is the data, and it's stored on Celestia or another mechanism. So, Katerina, you have a question here, please.
Yes, I've got one question. Is how? I mean, can we really verify the transaction since we don't know what are the other transactions that were put it in the same ZK rollup that O transaction? I don't know if I'm clear, but
I think I understand what you're saying. Like basically, the sequencer decides of the order of execution. The same way a miner decides on the order of the execution of the transaction. The only difference is that the sequencer here will sort of compress the transaction into the state, what was before and what was after. So you can know if you follow, I mean, it's a detailed implementation, you can know what happened. That's not a problem. You can actually have a protocol where every transaction that happened in the network would be available, but that's independent completely of the compressing itself. Am I clear? I'm not sure. I think
yes, of course. So this supposes that we have a separate database that stores the transactions, and then we can look at the transaction done before and after, so that we can verify the transaction.
No, you don't need to verify. The proof verifies it for you. But what you're asking here is a bit different. Is how do I have a block explorer, right?
Yeah.
Okay, that's a very good question. So a block explorers are, so you need to understand two things here. The first one is, today you have, what ZK brings is they bring a new type of validators of the system, which are the sort of it's the one you care about when you look at the security of the system. The indexers are a bit different. They don't care the same way. So to answer your question is, today when you look at Ethereum, you have three type of nodes, which are mining full node, non-mining full node, we're just validating everything that happened, and you have light clients, light node. Okay. In a ZK rollup environment, you have three things. You have a sequencing node, a non-sequenced indexing node. Basically, you have the guy who run the provers and verify everything. You have the indexers, the people who actually who cares about what's going on at every transaction. You have the succinct full nodes, which are the one who just take the proof and just update the databases. It doesn't care about what happened within the mix. And you have the light client, but even the light client doesn't make sense anymore because there is no need to have light client anymore. So when you look at the ZK rollup, what happened is you have two gossip network, if you're familiar with that word. Gossip network is how transactions are broadcasting to everyone in the network. So you have the gossip network of the indexers and the miners or the sequencers, and you have the gossip networks of the succinct full node, of the ZK full node. And those are two different gossip networks. Make sense?
Yes, thank you very much. Very clear.
Okay, great. So any more questions? Okay, great. Let's continue. So now just very briefly about Starknet. So Starkware. So Starkware basically started 4 years ago, and we started with the first project called StarkX. And StarkX was this what we call single DApp rollup, single DApp L2, which only do a few operations but does it very, very well. So StarkX does three things well, which is minting of assets, trading, and transferring. StarkX was super successful, been used by Diversify, by Immutable, by Sorare, by DYDX. So to develop StarkX, we developed a new, what we call a virtual machine, a new, like the EVM, but for ZK, called Cairo, which means CPU air. It's like it's a way Cairo works. And after we developed Cairo, we created Sharp, and Sharp enables us to have multiple programs proven within the same proof, a shared prover that's exactly what Sharp is. And once we were able to have this shared prover, what we were able to build on top, and this is what Starknet is is an operating system. And Starknet is technically an operating system running on top of KRYPTOSPHERE. Okay? Where the operating system manage the state, manage cross-contract calls, manage L1, L2 communication, deployment, like the address mapping, how storage is managed, and so on and so forth. And so we were basically sort of started with something very concrete, very small, very down to earth, to bring, to build the tech that we now use to build Starknet. And so Starknet has been actually in production, on testnet for over a year and in production for over 4 now. So Starknet, we are 60 now, we are rich, we do a lot of research, cool stuff, Fry, Cairo, SHAR, Validium, Volition, plenty of stuff, look it up, DAM, DeFi pooling, L3, plenty of things that you have a look at. You have Shaman where discussion happened there, Shaman is community.starknet.io, plenty of cool stuff there. A bit of numbers, just to blow your mind. We did $350 billion of trading, 105 million transaction, $1.5 billion locked, 30 million NFTs minted, and all those users are using currently Starknet. Yes, there is another hand raised, so please reach out.
Is there any advantage of StarkX over Starknet?
So that's a very good question. And the short answer is, in the short term, yes. Because think about it this way, a CPU is always slower than an ASIC. And StarkX is an ASIC. Starknet has a much bigger overhead. So for now, StarkX is a lot more scalable than Starknet. So StarkX can do, for instance, 300 TPS to sustain for transaction, etc. When Starknet is currently very limited because we are improving the performance right now. So, but even then, whenever we go to we go for later phase, I still expect StarkX to be more faster because it's simpler. It's a simpler system. But the point is, at some point, and that's actually what we discussed in the blog post called Fractal L3, is we show that we can actually have StarkX over Starknet and Starknet over Starknet. You mean that if someone could deploy their own Starknet on top of Starknet and have their own blockchain of sort, trustless, that exists on top of Starknet and pay very little fees for all of that. And the way I like to think about those is similarly that to how internet works. I don't know if you're familiar with how the cable of the internet works, but basically internet means the interconnection of network. And so the way usually your network work is that you have like your house is connecting to your street, which is connected to your neighborhood, which is connected to the city, which is connected to the state, which is connected to the world through transoceanic cables. There is 40 of them. You can look it up. And so every time you are moving from a network to another, and you basically, most of the activity actually happen locally. You barely go to the US when you're when you're reaching out on the internet. You usually, when you work with Netflix, they're using local machines to make it faster for you to access your content. So to answer your question is, there is usage for StarkX. There will be usage even after Starknet goes live, like very much live and much performance. And there are also, but in the long run, I guess you're right, Starknet will probably take over. And so we already in the multi-app phases, Constellation, we're live. Since then, we have 15,000 active Discord, 60 different projects. Now the numbers are outdated. We have more than 100 Cairo dev at the moment, working extensively on various things. Independent dev, reaching out, building random and cool stuff. People like Guilty Gyoza writing AI on top of the blockchain and physics engines, and Bricks, which is doing like a Minecraft on top of Starknet. We have Cairo Chess, which is like an implementation of a chess game on top of Starknet. We have someone working on the inference form machine learning model on chain where you can output from sklearn to Cairo. if you're familiar with those words, basically doing AI on the blockchain. So you can wonder what it does. It's useful for it. There's been a use case for this. I can dive into, we have Influence, we have Loot, we have Dope War, we have like plenty of other projects building right now and something that are very exciting. We have Snapshot X, which is a way, like a unique use cases where you can do voting on L1, but on L2 trustlessly. Basically what excites me when it comes to Starknet is that people are building things that couldn't exist before. It is not just cheaper fees, because cheaper fees is nonsense. It's a commodity. Cheap fees will arrive. We will get cheap fees, but you don't want, that's not a selling point. No one fucking cares. What actually matters on Starknet is that computation is cheap, so people can do crazy stuff. And this is what gets me excited when I'm trying to explain that to people. Okay, so a bit of what you can do. This is also outdated. This is existing. This should be live already, and this already exists. We have working with plenty of teams right now, building plenty of stuff. And if you are a dev and you're interested in building stuff, just reach out. I have a candy store and candy shop of project, from security, from fathers to compilers to auditing to education, dev tools, application libraries in all domains, API, decoders, debuggers, whatever you name it, it's available for grab and for chatting. So feel free to reach out. My Telegram, my DM on Telegram, on Discord, on Twitter is open, so feel free to reach. So that kind of covers the sort of first set of things I wanted to chat about. And now, yeah, let's go for the questions.
Me, I would have one first question is why can ZK rollups can coexist with the future consensus layers of Ethereum?
Oh, there is no, so as I said, an L2 is completely orthogonal to the consensus. So Ethereum could have a proof of authority for what I care about. ZK rollup would still work from the perspective of if you trust the consensus assumption.
Would it be possible to deploy Starknet on other blockchains without a lot of changes to the infrastructure?
So the main thing that prevents us right now is actually if it's not the VM, if it's VM compatible, it would be half a second, but we don't have time. I have enough features to develop for 2 years. So when people ask me, can I deploy it on whatever? And I'm like, I'm sorry. I remember I had a discussion where I literally told the guy was like, even if you give me $10 million right now, I won't be able to make it happen. It's just the way it is. We don't have time. Carolina, please, you raise your hand again, or is it just
Yes. Another question about bridges between two L2 layers. Are you working on this kind of project? I heard about Connext, I think, that enable to
there is a bunch of
go
ahead, Karen, please.
So the question is, we want to make direct bridges between two L2 layers without having to go through the layer 1. Are you working with this kind of project, and how do you see this implementation in terms of security and the later perspectives?
So okay, that's a very good question. The answer is yes, we're working with them. We are, so you can't, okay, so the notion of bridge is a complex one. The thing is, the cool thing about L2s actually, that they can have technically trustless bridge, true trustless bridge between different L2s. But what's going on is that there is multiple projects doing bridges. There is Synapse, there is Hubs, there is Composable, Seller, Wormhole, obviously for everyone who knows about. Who else? Socket, which is an aggregator for bridges. AnySwap. I mean, I'm missing some, I'm sure. And so each one of their own tech and implementation. The story goes, we are trying to work with all of them right now. What prevents us from working is that we don't have any bridge. Like you cannot deposit token on Starknet because the performance are not very good yet. So right now, Starknet mainnet is more like a tooling, a testing environment for devs. It's not ready yet for for users to really actively use it, like in any meaningful way. So we're sort of holding back the bridge there to avoid creating too much traction while we can handle it. But it will change in 2 months, let's be clear.
Great, thank you.
Okay, Maximilian?
Yes, thank you. How easy it is for classical developers to master Cairo, and do they need to have some knowledge in cryptography?
Absolutely not. For Cairo is a high, relatively high level language. You don't need any knowledge. That's a black box. That's the beauty of it. It's a black box. And so the story here is, funny enough. So I was talking to Julien, who is the founder of Argent, which I guess you know, Argent the wallet. And even like 4 months ago, when the tooling was shit, because the tooling changed very, very fast. Like if you knew things that were 3 months ago, they are no longer true by your mind. It's only that it was easier for him actually to deploy stuff on Starknet than it was on Ethereum. So the story goes that it's a new tool chain. It's actually probably, if you don't have solidity, it's actually probably easier for you to pick up than if you have a solidity background. And truly, and I'm just saying that if there is dev in the assembly, is I think Cairo is probably the most valuable language in the next 2 years. And any early adopters of Cairo will probably be fine. We are all going to make it.
Okay, thank you. Yeah, I agree. I'm asking this question because I'm indeed interested in joining the adventure.
So try it out. Try something. Build something. Build something.
I have like a mathematical background, and I would like to know what are the skills if I want to participate in developing kind of the research part. So
the research part, no, the research part is done by us, and to be honest, it's PhD level of cryptography, whatever stuff. Like it's one guy in my team invented a new FFT algorithm. So it's like, it's like literally like it's called ECFFT. You can look it up. It's a very funny thing. It's crazy thing. And so on the research side, there is plenty of things to be done, and you can chat over this on Discord. We have like very cool Discord. You can read the Cairo paper, but to be honest, if you want to actually build stuff, you don't care about that. It's a black box. I mean, you're the same way you can understand the theory behind GPUs, but it doesn't help you write a program on the GPU.
Okay.
Same thing. So you don't need to know, but you can use it if you want to do, like, for instance, right now there is a bunch of people working on various libraries for mathematical usage, like derivation and logarithm, exponentials, all sort of things. There is this guy working on an output of sklearn. So sklearn is a very famous machine learning libraries where you can output, let's say, a linear regression, which is a very simple type of machine learning model, into Cairo, where you can just directly output a contract, which is this with the weight and all the training already happened. So this is the kind of thing you can build with the mathematical background. Although you can just build, like, cryptography. Like I'm asking, there is a project open if you want to pick it up, which is implement RSA verification. For instance, that's cool. That's small. That's something you can do. But you need to, there is probably missing tooling that you need to build on the way. And that's pretty cool. So just go on the Discord. I'm going to put the Discord link on here. Let me send it to you on the chat. And let me just actually change to be for it not to expire, because if you don't know if people would see it. Okay, here it is. Here it is. Okay, great. So yeah, just try it out, and feel free to reach out if you have when you start a project, so we can discuss. I'm sure we have a lot to discuss.
Yeah. Yes. Okay. Thank you very much.
Sog, I know what the last name is.
Yeah.
So, please,
so I've seen that there's a lot of expectancies about writing Solidity code and transpiling it into Cairo.
Yes.
But is it really that much important? Because
that's a very good question.
Yeah.
That's a very good question. And so the answer from my perspective is frankly, no. What I'm seeing is, I mean, the only use case and good use case so this is Warp. What you described is called Warp, is what makes Starknet EVM compatible. But we don't really market it this way, because the thing that the way you write in Solidity is different from the way you write in Cairo. Because when you write in Cairo, in Solidity, you made assumption on computation. You simplify stuff. You made things that were very, limited for Solidity reason. In Cairo, you can remove that. So my answer here is, the only good use case I have for solidity like this is people like Paraswap, like aggregators, where they have they have one single code base and they want to deploy everywhere. And that makes sense to me. Like it makes sense for them to use, a transpiler because they have a bunch of tests. It's like already tested. They want a single code base. Makes sense. But if you want to make something that is unique, that is very Starknet oriented and has just use every specific advantage of Starknet, you should definitely use Cairo. Actually, I'm asking here. We're actually also looking to make what we call Crust, which is Rust to Cairo. So if there is compiler expert, feel free to reach out. I have things to do with you. Any more questions? You raised your hand again? No, it was on purpose. Okay.
Thank you very much. I may have another question. You often use some metaphor of a sudoku. I didn't understand it.
Okay.
Can you explain it for everyone, please?
Sure. So the sudoku is about ZKP. So Starknet Starkware doesn't really use the zero knowledge aspect of ZKP. Zero knowledge, people think of privacy all the time. They always think of privacy. Rightfully so, because that's the first use case, what people are thinking about. They don't think about compression. So the example people try to give when they give ZKP to give a sense of ZKP, although it gives absolutely zero intuition about why ZKP brings scale. It explains why ZKP brings privacy. It doesn't explain why ZKP brings scale. Okay, just very clear. So there is a bunch of famous examples when it comes to ZK, which is where is Waldo and the cave where there is a door and the colorblind guy and whatever. So though I hate those examples because I think they are very weird to sort of get your hand around it. So I use another example, which is a good one, which is sudoku. And the question is the following: how can I convince you that I have a solution to a sudoku without revealing that solution? Okay. So today, I have a solution. So what will happen is that I will have to show you, and then you have all the information. We created Cairo, and the compiler is also Cairo. So let me just go back to this and just finish afterwards. So the reason for this example is to explain the zero knowledge aspect, what zero knowledge does. And so here is an example. We have a sudoku in front of us. Jules, I have my sudoku. You see the sudoku. So we're going to write it on. We're going to a room. We're going to close. This room has on the floor. There is like with clay. There is like the sudoku written, and there is tiles on it. There is tiles with numbers. Okay. All the tiles have numbers, and so I take all the tiles are 1 from 9. Like nine times, right? So the rule of sudoku: 1 to 9 in rows, 1 to 9 in column, 1 to 9 in squares. So what you do is we're going to put the sudoku, the open numbers of sudoku on the board, and you and I are going to agree on this is the board of the sudoku, right? Okay. I'm going to ask you to turn you, and I'm going to take the tiles. So the tiles have like something to close them, even the ones that are already exposed, right? So I'm going to take the tiles that were on the side, and I'm going to put them on the sudoku. I'm going to close all the tiles that I put and leave open the ones that were before. Now you turn, and you look at the tile, and you see that I didn't change the order of the tiles. I just put tiles on the sudoku, close them, and now I ask you to close the remaining one, the one that were there before. Okay, so far so good. You understand? You picture it?
Yes, very good.
Okay, great. So now I'm going to ask you. So all the tiles now are closed. The only thing you see is closed tiles. And those tiles are, have numbers behind it, but they're closed tiles. All the board is covered. Now I'm going to ask you to pick randomly without me. Now choose a row, a column, or a square. Okay? Let's say you choose a square, the middle square on the left. I take that square, I put it in a bag, I shake it, and I give it to you. What do? You verify that there is 1 to 9. Okay? Now, let's say I lied and I didn't have the right solution, and you got lucky. Then you're going to see that there is 2, 2, or 2, 9, or some number missing, right? Okay. So And then you know that I'm a bullshitter. I lied to you. I don't have a solution. Otherwise, I would have put the right solution. Okay. So now then you would have busted me, and now you would not trust me anymore. Okay. So now let's say I'm lucky, and the numbers goes to 1 to 9. Okay. So I was lucky once. Now let's do it again, and again, and again, and let's do it 1 billion times, 100 billion times. The likelihood after a while that I managed to lie to you that many times in a row is so small that you are convinced that I had a solution. Because the likelihood of me lying to you would have been, I would have won 5 times in a row to the lotto for me to win this, to lie to you this successfully like this. So this is why you are convinced, because I couldn't have known if I didn't have the right solution. But you didn't learn anything about the solution. Why? Because you don't know what were the ordering of the tile before I shake them, which is why I shake them. Because so now you don't know in which order they were on the square.
Okay, so you are talking about a probabilistic approach?
That's exactly what ZKP are. The initial name of ZKP is called PCPs, provable probabilistic checks. And so what ZKP brought and what Shafi Goldweiser and Sylvie Micali brought to the world is the notion of probabilistic proofs. And this is what ZK are about. They are all about probabilistic proofs.
Okay, good. Didn't know that, thanks.
Right? My pleasure. Exactly. Any more questions?
There was Louis question about Cairo languages in the
So
chat.
we invented Cairo. It's a very good question. We invented Cairo. Why? What the comparator of Cairo is Cairo. So that's it. That's easy. So why we invented Cairo? It's maybe a more interesting question. So in VK, you live in a world like in traditional computer. When you work with your computer, you work what we call it an x86 environment. And your x86 environment is where your CPU lives. It's a binary word where everything is bits and bytes. Okay, so something that the cheapest thing you can do on your CPU is a XOR or an AND or an OR. Those are super cheap things to do in the CPU. But in a ZK environment, you live in an arithmetic environment, meaning the native operation of your environment is addition, division, subtraction, multiplication. And so in ZK environment, division is free, but XOR is expensive. On a regular CPU, a XOR is free, but the division is expensive. And so we had to create a new language to take advantage of those specificity, that's unicity, and create performance. This is just one example of what makes Cairo unique. There is a bunch of others, which I don't want to dive because they're a bit more complex to understand, but this one is very clear usually for people to grasp. It's not even CPUs, it's a different type of programming paradigm. It's more than this.
Okay, so can you hear me?
Yes, we can.
Okay, so it's not depending on the kind of CPUs you're using, just okay.
No. The difference is the programming paradigm. One is, regular computers are made for bits and bytes. ZKP live in an arithmetic environment where you use everything. Your most basic element you're using when you're using a computer is bits and bytes, right? In ZKP, you're using what we call the field element, which is basically a very large uint.
Okay, yes, the felt.
The felt, yes, field element. So it's a uint between 1 to a very large number called the prime of the field. It's not that interesting, but we can consider it to be a uint for all purposes.
Okay, thank you.
My pleasure.
I have another question about Starkware environment. Is how do you plan to build a new relationship with companies? Are you going to tackle on the only Web3 project, or do you try to go to non-Web3 project that are going to?
We let people come to us.
Okay.
That's why I'm coming here, to convince you youngsters to come and do cool shit. Because what people find, that's actually something of my theory about innovation. It's not mine. It's actually, I didn't invent that. It's Chris Christensen, with the professor from Harvard who died recently, called the innovation dilemma. We wrote about that. But basically, all innovation, so it's called innovation comes as a toy. And another thing that people don't seem to understand is that tech do not democratize. It's people who become more geeks. I'm not going to reach out to people who don't give a fuck about blockchain. I'm going to focus on people who give a fuck about blockchain. And those guys are the people who are going to bring their friend, who all of a sudden we're going to care about blockchain, which is exactly what we're seeing with NFTs. The first people who care about NFTs were hardcore blockchainers, so big Ethereum guys, hardcores. But now we are getting fucking, Paris Hilton is actually not a good example because she's actually a hardcore blockchain woman. But let's say Tom Brady or Jimmy Fallon and all those guys, they just come now to NFTs. And it's not because we made the tech simpler, it's just because it's cool enough now. So when you ask me, will we go after, I know, Facebook and I know, Robinhood and who else? No, I won't, but they will come.
Nice strategy.
I mean, it's just the way it is. I mean, that's actually how things goes, and actually how we witnessed it coming since the beginning. TikTok worked with Immutable. Would have think TikTok would make NFTs? Would have think that Disney would be working with Vivi, and would have think that Nike would have buy a digital sneaker company? It's not because we don't democratize. People become more geeks. Very important.
That's nice motto.
No, truly. Anyway.
Okay, good. Does anyone else have a question? Or?
Yeah, go ahead.
Hi, I was wondering, is there any reason in the future for the apps to build on top of L1 instead of L2?
That's a very good question. The short answer is yes, but we'll see. You can't predict the future. Like there will be application specific to that, to L2. Like the future is not black and white. It's never black and white. And CryptoPunks will remain on L1 because they are the most expensive NFTs. Well, not ape are more expensive, but you get the point. If L1 becomes cheap, then NF project will come back to L1. If L1 becomes too expensive, then you will have only very expensive operation happening on L1. And it will be like a sign of boasting to be, oh, my NFT is on L1. So we'll see. And I'm no one to judge. Project will just decide based on where the business case for their application.
Okay, thank you.
My pleasure.
Good. Anyone else?
I have a question. Earlier, you spoke about the different types of nodes being like sequencing nodes, and then them using different gossip algorithms. Can you speak on that again?
Gossip network.
Yeah, gossip network. Can you speak on that again? I was a little
sure.
confused between the differences of that.
Okay, so have you ever wondered how transaction goes into the network on Ethereum? It's literally, we call that the gossip network because that's how the node gossip with the people who are connected to them.
Yes, I was talking about, you said there was two different gossip networks between the indexers and the sequencers,
yes,
right?
Because the indexer, no. The sequencers and the indexer would have the same gossip network, but the light full node would have a different one composed of proofs.
Okay, all right, thank you. That's where I was confused.
Yeah. And that's why we post something called checkpoint, faster finality with checkpoint. It can provide the same dichotomy. Actually, goes a bit deeper. There is actually, you can have a lot of this design space there. I won't dive too much, but you can have a very cool design space there.
Thank you.
My pleasure. Yes, sorry, the question. Yes. Okay, great. That's my thing. I wrote that thing. So DAM, you have to understand. So the concept behind DAM, it was, how can we have cross L2 liquidity? And the way you need to think about it is, about DAM is imagine you have, instead of having one single market maker, you know, an IMM, you have different IMMs, but working with the same liquidity pool. Okay? Meaning the LP, so the reason why usually IMMs cannot work across multiple L2s is because they have a synchrony assumption break. Because each L2 doesn't have the same time, don't live on the same environment, so they don't share the same clock. They're not coming back in and out, you know, at the same time to the IMM, right? And so what DAM says is, okay, let's spin that problem into its head and say that what risk does this non-synchronicity brings? And the risk it brings us a risk, a financial risk for the LPs. So what if we were to, instead of taking that from the technical perspective, but turning this into a financial problem, which is, I'm going to get more wrecked if the movement are too big. What if we spin into its head, and now we are saying, the LPs are willing to accept that risk. And now the cool thing about financial risk is that there is many tools to mitigate them. And so the point is to turn the technical problem into a financial one, and then implement various mitigation techniques to make it less pregnant and less traumatic for the LPs. Does it make sense? Okay, great. Maximilian, please.
Yes, about DAM, how is it possible that the different L2 interact with the L1 pool without having to sending the information to the other L2?
That's exactly what I explained.
I find it quite magical because...
No, it's not magical. It's not magical. It's very far from magical. It's not magical. It's not even a great solution, to be honest. It's not perfect. It doesn't solve what it does, though. It takes a technical problem and turning into a financial one. Do you understand what I'm saying by that? What I mean by that is...
Yes, absolutely.
So it's not magic. It's just saying, here is a pool of liquidity, and me as an LP, I'm accepting the risk of getting fucked twice. Instead of getting fucked once, when I'm working on Ethereum, I'm accepting to be fucked twice, and 3 times, and 4 times, depending on how many L2s are connected.
And from the point of view of the user, if like the price can be different on some L2 between different L2, no?
Yes, exactly. That's why you have arbitrageurs, and that's why you take a bigger LP risk by being on them.
But because it's the same L1, it's the same pool. How can? Do you see my point? Where
I fully understand your point.
Is about to send the transaction,
I fully understand your point.
Price, yeah.
That's the thing, because you are. What I'm saying is that imagine, let's say you have different price oracle, like price formulas on each L2. Each one evolve independently, but they can all settle against one liquidity pool on L1. You follow me now? Basically, it's like I have one single pool of liquidity for multiple pricing function. So that's why I'm saying that when I get fucked 3 times. Because now there's 3 pools that are going to fuck me. 3 prices are going to fuck me. You understand what I'm saying here?
Yeah, absolutely.
What I'm saying is that you need to understand what risk an LP on an IMM agrees on. He agrees into his impermanent loss. What I'm saying is, DAM tells you, okay, I'm taking that risk, and I'm not shying away from it. I'm just saying the LP that goes into DAM agrees to it. And so it works actually very well when you don't have any impermanent loss, like on Curve. It's a bit more tricky when you have any swap time of IMM, because there, let's say you have three different L2 connected to the same DAM, then I'm accepting 3 times, in the worst case, the impermanent loss. Instead of exposed to 1 impermanent loss, I'm 3 units of impermanent loss. And so now what you can do is have reimplement on top a syncing mechanism between the L2 to avoid you to get too much fuck, basically. You can have like an active market maker on top of DAM to make sure that you don't get too much fucked by the system.
I see your point. Thank you very much.
My pleasure. It's not magic. It's really everything but magic, in the sense that it doesn't solve much. What it does solve though is, let's say it just speeds the problem on its head and says, maybe we can just accept it. And if accept it,
I see the point of view now. Thank you.
Great. My pleasure.
Okay, thank you very much. Does anyone have a last question for Louis? No, nobody. So,
amazing. We're on time. Thank you very much. Awesome. So listen, if you want to go into Starknet, go on the Discord. I gave you the link. If you want to chat with me, my Twitter is open and we can discuss. You know, there is many opportunity on either for dev on Starknet and even for educators and people who care about the tech, but not necessarily technical. You can write content, you can write many things, and I'm happy to chat with you if you are interested by doing such a thing. That's it.
Thank you very much for everything, Louis.
My pleasure.
Thank you very much.
Instructive presentation. Thank you.
My pleasure. Have a great day, guys. Bye-bye.
Bye.
thank you. Bye.